Hello everyone, welcome back to Codewars Coders. Today we'll be starting with fundamentals of computing for data science. This will be our lecture number 1. Now, in our earlier classes, we had studied about a subject which is known as FDA, Fundamentals of Data Analytics. It is a continuation of that subject as both these subjects are interrelated to each other. So this lecture will mostly be like your data analytics part that we've already done earlier. Take this as a revision lecture, and for those who have not done the FDA lecture, please listen to this lecture carefully because this will be the base for our further topics. So let's start. So first of all, there are some import statements that you should know by heart. One is your pandas, one is your numpy, one is your matplot.pyplot as PLT, and one is your C1. C1 is for your visualizations. Matplotlib is basically your plotting. Numpy and pandas, I hope you'll be knowing. Now DF, data frame. What is DF? Data frame. pd.read_csv and the file name. Then check your data. Head gives first 5 lines first. Shape gives row, comma, column. Info columns give names of columns. This is describe is used to see the property of the dataset. Property of attributes of dataset. Structure. So this is what you should check in your data first. Now, these are some statements that you need to memorize. First 5 rows, you'll use head. First 10, you'll use head, but you'll give a parameter of 10. Last 5, tail, rows and columns, shape. Column names, df.columns, data types, df.dtypes. Basic information, df.info, descriptive statistics, then null values, then duplicate, and then remove. Now, when we talk about D types, we can encounter an int value int64, or we can encounter a float value. We can encounter an object or a boolean value, or we can say a date time value. Then it could also be a category. And the last one is time delta. 64 difference between two dates. I hope this part is clear. I don't think any explanation is needed here. So next is data frame creation. How do we do this? This is done in the form of dictionary, where you write the key as the column name and value. You have the values. I'll show in the form of a table. Let's say this is name, age, and marks. A, B, C, 20, 21, 19, 85, 90, 78. So this is how the table would be given, and then you have to convert it into a data frame. Using list, the difference will be that in the form of dictionary, the key will be the same, but in the value part, we'll be using the concept of list. To access a column, we write df of column name. Then for multiple columns, we mention the column 1, column 2. And to add another column, just you write new underscore column is equal to and the operation you want to perform. Let's say you want 40% of your marks. So df of marks or those who have marks greater than equal to 40%. So greater than equal to 40. It comes mean, median, standard deviation. This we can find out using df of column, the column in which you have to apply the operation. Then you can use dot mean, dot median, dot std, dot var, dot min max, and dot describe. Okay, so count is for this one, mean is here, median, standard deviation, minimum, max. Now, descriptive statistics, compute descriptive statistics for discount. Let's say you take a column name and you write dot describe. So you can write like this, a single query. If not asked, if they ask individually, then you can write dot mean, median, std, min, max. For multiple columns, we know I had explained. You write df of column 1, column 2. And then you can write dot. Next is skewness and kurtosis. This is extremely important. Skewness where you use dot skew and kurtosis you use kurt function. For several columns, you can use the concept of a for loops and then use df of column dot skew or dot cur. Now, understanding the interpretation based on the value we get, if it is approximately equal to 0, we reach the concept of approximately symmetric. Greater than 0, right or positive skew. Less than 0, left or negative skew. Let's say if it is a positive skew, the tail goes to the right, positive. If tail goes left, negative. For dot curt, if it is about 0 only, so that is mesocurtic, that is normal line. Greater than 0, leptocurtic, and less than 0 is platycurtic. It's really important to write the interpretation also along with getting the output. Next is histogram. A histogram shows basically the distribution of numerical data. As you can see, we have taken the example where we use plt.hist. You write the column name and you write how many bins. For here, in this case, we have taken 10. So basically, it controls how many intervals or bars the data is divided into. Here we can say approximately 10 intervals. We wrote bins is equal to 10. Then similarly, kernel density estimate, it gives a smooth estimate of the distribution. where we use KDE plot. Histogram is in the form of bars and KD is the smooth curve. Next is your scatter plot. Scatter plot is used to show the relationship between two numerical variables. Like we can say SNS dot scatter plot x and y can be replaced by any other column. Or we can also write SNS dot scatter plot data is equal to DF. This is a data frame. X is equal to column 1 and Y is equal to column 2. There will be one independent or input variable X and one dependent or output variable Y. Similarly, count plot is used for categorical data. Suppose we have to plot count of payment method, so you use count plot for that. Then example of some categories could be UPI, credit card, debit card, cash. The weight height of each bar is equal to the number of observations they have. This is important. Next, box plot is excellent for comparing distributions and detecting outliers. Now, box plot is basically a graph like this, where this shows minimum, this is Q1, this is Q2, this is Q3, this is your maximum. When we talk about after minimum, this is a 25%, this is 50%, this is 75%. And IQR is basically your Q3 minus Q1. So by this you can, this is the syntax SNS dot box plot data x and y. This is the syntax. And box plot tells you median. Median is your Q2. I'll write a median Q2. Outliers are points that outside the whiskers are generally considered potential outliers. Now, group by is a very important concept for exam. Now, so let's say we are told to compute the mean order value per device type. So, based on the device type, you club the order value. Based on this, what you do is you join this or you take mean of this and you get your answer. Similarly, when you have to apply multiple statistics to the same set of columns, you can use dot aggregate. Then you can either use mean, median, standard deviation, 1, 2, 3, like this. Similarly, if you have to group by city, you'll just replace it by city and you have to club it using the order value. Next, find the city with the highest average order value. We can use city, group by city, and order value dot mean. Similarly, you can use dot IDX match, city underscore AVG, where we have the selected rows itself, and average order value is dot maximum. Value on the index, as they both are separate. If you want the value, you have to use max. And if not, you have to get the location or the ID. You use ID max. A bar chart. A bar chart is a chart that shows the variation based on, let's say, average delivery days per city. So first you use group by for cities and delivery days dot mean. Then dot plot kind is equal to bar. Or using cmon you can write here sns dot cmon data is equal to df, x is equal to city, y and estimator is equal to mean. Now count plot is basically used for categories, whereas bar plot is used to compare aggregates such as mean. This is a really important differentiation between both of them. Next is correlation. Correlation is very important. Correlation tells us the strength and the direction of a linear relationship. Now let's say we have three columns, let's say, and you write df of columns dot corr correlation. You will get a matrix which is known as a correlation matrix. Its value will always lie between -1 and +1. When +1 shows perfect positive, +0.8 strong positive, +0.5 moderate, 0 means no linear, -0.5 moderate, -0.8 strong, and -1 will also, of course, show perfect negative. Now let's see if you get a value of df dot correlation as 0.72. That means there is a strong positive linear relationship. Whereas if you get it as -0.65, that means there are moderately strong negative linear relationship between the two columns. Next is correlation heat map. Now correlation heat map is basically drawn between two or three columns. So let's say first you create the data frame containing those specific columns. Like we needed some specific columns. Then you create the heat map using sns.heatmap where you put the correlation matrix. Then R naught is equal to true. Display correlation numbers inside the boxes. R naught is equal to 2 is used for numbers inside the boxes. This helps in getting to know what is the number associated or what is the correlation number inside the box. When it is closest to +1, we know positive relationship, -1, we know negative relationship. Don't consider the diagonal values because every variable has correlation one with itself. So therefore, you'll have a matrix like this. Here you can have any set of values. So that is what. Now, when you have to check for null value, you check first of all how many are there, and then you use drop now or you use a imputer, that's one new, but this is how you work on them. Then to check if it does not automatically remove nulls unless asked. Now, when you have duplicate rows, so df dot duplicated dot sum, you will know how many duplicates are there. Now, df dot drop underscore duplicates, these will drop or remove all the duplicates. To check again, you can again set the sum like earlier. To checking the null values, we got the sum. Similarly, for this also, you can see the sum in order to confirm whether your operation is successfully completed or not. Next is compare mean energy consumption across room type. Here you'll use group by energy consumption dot mean. Similarly, for visualization, we could have used a bar plot, like we can see here, using C1 library. C1 library. For payment underscore average, have highest average cost efficiency, payment method, cost efficiency dot mean. For highest, you'll get your dot IDX max. For the value, you will write max. And payment, similarly, now you can club them together and get it printed. Similarly, how to convert yes, no to binary. So we use the concept of map, dot map, and then we put a dictionary of a key value pair to get one mapped with one, yes, and zero mapped with no. Another alternative would be using of a lambda function, but we mostly don't use lambda functions. So def motion binary is equal to df dot apply lambda x 1 if x is equal to yes, else no, 0. But map is a cleaner way to achieve the end goal. Rolling mean. Now let's say we have to calculate the 3R rolling mean. So first of all, we'll sort the data frame. Then we'll calculate the rolling mean using dot rolling, and according to the parameters given to us, let's say here we were given a 3R rolling mean and mean. Similarly, rolling 3 means calculating the average of the current and previous two observations. For our 1 and 2, you'll have insufficient observation, but from R3, you'll have one observation here and one here. So you can take the average now and you can compute your value. If you want to plot, you can plot it also. If 3 are rolling mean. Then if the question says 3 are rolling mean, ideally data should be sorted by time, but you should sort it even if not mentioned. If not mentioned also. If there are multiple observations per hour, first aggregate appropriately before applying a 3-hour. Aggregate function is very important in this case. Ultimately, if you don't apply the aggregate function, how will you get to achieving the aggregated value for a specific type? Let's say for ID1, how many transactions have been done, the mean average value. Let's say I'll explain it with the help of example. Let's say there is a person 1 who has done 3 of X, Y, and Z, and there's a person 2 who has done A, B, and C. So in order to check how much has 1 and 2 spent in the mall, so you need to aggregate them, and this is A plus B plus C. Then only you will be able to get the value. So this is what I was trying to say. Ultimately, you will have to calculate the mean or the maximum value. This visualization cheat sheet you should know. When I talk about distribution, you'll have to use here histogram or KDE. Numerical distribution histogram smooth, KDE. Relation between two variables scatter plot. Count of categories count plot. Compare numerical distribution box plot. Compare means bar plot. Trend over timeline plot. Then relation among numerical variables using correlation matrix and visualize correlation matrix in heat map. I hope this is clear. Now this is all what we have covered till now summarized into a single table with the syntax along with it. Like for histogram you can use sc bond sns.kd per plot. This is a hist plot, KD plot, scatter plot, count plot, box plot, bar plot, then line plot, heat map. Then this is dot value underscore counts dot plot kind is equal to pi. This one is new. Then area plot. Then bar chart we have done. Bar chart is basically here where we are using is for category comparison. That is, we apply the aggregate function first and then only we apply the, like here also see df.groupby based on city, you're aggregating the values and then plotting it. Similarly, this is also the same. I hope you'll be able to do this. Most probably you get a histogram or a scatter plot, or along with that we can give you a heat map. Another one would be a box plot, but a box plot was covered in detail in your previous semester fundamentals of data analytics. So this is what we have already seen in the table that we are seeing right now. This is just a shorter version of that. I hope this also would be clear. How to identify based on the statement rolling mean means line plot, correlation is heat map, trend per hour unit time, average or mean per category bar plot, across categories box plot, relation scatter plot, frequency of course you can say count plot, and then smooth distribution always KD. Now this is a sample dataset that I want you all to save using as a CSV file. Open notepad, copy, okay I'll write it, open notepad and copy this dataset and save it. Now I want you to try these questions out. We've mostly covered the format and how to use them. We have covered all the questions. This is just a summary, or you can say a gist of whatever types of questions can come from this topic, and we've covered all of them. So I hope you all will be able to do these questions. Next, one important thing is that these 7 visualizations are very important, irrespective of you don't know the others. That is okay, but these 7 are super duper important. PLT.show. This is also important. This is just to show it, like when you upload a YouTube video, you get the option of public, private, and unlisted. There you get the option of scheduling, right? Or instead of show, you could write save also, and you could give the path or the file name. So that is also an option. Similarly, for skew greater than 0, I told you positive, skew less than 0, negative, and approximately 0 will be stable or symmetric. For plus 1 correlation, you will get a perfect positive, 0 no linear, and minus 1 perfect negative. Now suppose you have a scatter plot, and if we see that scatter plot is going up, you see a positive relationship. When it's going down, a negative. If you see a random cloud like 1, 2, 3, 4, 5, 6, then means weak or no clear relationship. For kurtosis, if it is greater than 0, leptokurtic less than 0, platokurtic, and approximately 0, mesokurtic. So thank you all. This was about today's lecture where we covered different types of graphs, where we understood how can we pre-process data, how can we analyze data. Though we have covered all of this in fundamentals of data analytics, but still this was a base for your further topics, so I've covered them in detail. Also, do remember to solve the last two questions that I've attached with respect to a e-commerce data set, because it will cover all different types of questions that can come from data science module 1. This is basically a module 1 covering all the basics. So if you have any doubts, do mention them in the comment section. I'll be answering them as soon as possible. Rest, if you like the video, do like, share, comment, and subscribe to my YouTube channel. So thank you. Bye bye.